Hey, the Average Joe here. Hey, today we're going to talk about IPS system. That's also known as an integrated piping system. So just what is that? Well, actually, this next week at the HR show in Orlando, you can come by our booth, HVAC Solution, or either the Takeo booth or the Williams, and learn more about these systems. Our software has been designing these systems for the last 20 years, but here just lately, under our wizard section right here, number 11 wizard there, IPS systems, we now make it very easy for you to answer questions and build this type of system. So these systems are especially well designed for apartments, condominiums, dormitories, nursing homes, projects where you have lots of domestic water usage as well as hydronic. So typically, you might have a hydronic system and domestic where there might be as many as 5, 6, 7, 8 pipes in the system. This integrated piping system, you only have 2 pipes running around the project. A hot water pipe, a chilled water pipe, cooling, and then the domestic water piping down here, which comes off that hot water line, have a tempering valve, which mixes with the cold water to go to domestic fixtures. And then the chilled water line comes off there to go to the cold water fixtures. And you have fan coils on the project with a little injection pump that comes right in the Williams fan coil that brings water up off those single pipe system and takes it through the fan coil units and puts it back in. So on a single pipe system, we have cascading temperatures, and we'll look at that here. Uh, so our wizards, we can design all types of systems. We import loads, train, carrier, Revit, Elite. We answer questions, and these easy to use wizards build the air, hydronic, whatever type of systems you want. Today we're going to look at IPS, so we're going to do all the calculations. We can select equipment and then create schedules in Revit to do that. So file, open example. So I just want to open example. So if you come to our systems, this would be the new software that you're going to be getting this week. IPS, we have some examples. So we'll open this 4-story project here. We'll bring it in a new window here. So let's just zoom in on the heating. Okay. On an IPS system, you're going to set at the boiler the entering and leaving temperature so you can set a flow around the system. So that flow around the system, and if you look up here, there's 140 degrees coming there, 140 degrees there. But as it comes down through these loops, and they could be coming down or going up, you can set the project up however you want, but you'll see 140, and then that's going to take the load off that, inject it in 137, 134, 131, 130. So these cascading temperatures are going to mix and only allow, like we said, that we set the entering and leaving temperatures of the boiler, sets that flow around the system, so you're always going to have enough hot water. If you can't get, you'll see the little blue line down here. That's just saying, hey, your water's getting a little bit colder. When it gets down to around 100, I think 12, we set the temperature to the piping color to a blue, so you kind of know that. The same thing with the high, and then you'll have the injection of the domestic water coming in that line for the heating and cooling, right? Because that's you have 2 flows. Just look at these flows in a project. We'll click on a fan coil in here. You're going to have under key data, we need to go to cooling here because we have 2 scenarios. Cooling, the IPS system, we can see let's click on a pipe here, not the fan coil unit. In a pipe, we'll see under an IPS system the flows that's required. That's going to be for the heating and cooling, but then there's hydronic flow to meet the heating load in the project, 26, and then domestic flow to meet the domestic load in that system. So both those flows are in the project going around. Now, part of the fan coil system, we'll see this in our wizard, is going to be looking at the different types of uh, fixtures or types of projects that are related, uh, like you say, condominiums, apartments, dormitories, those types of projects. So now let's just go here to a new sheet of paper, new project. When it comes up, we want winter heating. We don't need to do economizer on this. Those are the scenarios we want. Our location, we're in Utah. Now I've got a new sheet of paper. Let's go to that IPS system wizard. We're going to simply answer the questions. So in this case, we want a load match single pipe system, and we want heating and cooling. So we'll do 2 loops. We'll do our mechanical room at the bottom. We could do 4 loops, 6, whatever we want. There'll be 6 loads per loop. We're going to alternate those loops on that piping. And then what type of fan coil systems or units we want. All the different Williams types there. This is where you'd enter the load of each fan coil. I've put some loads in there already. We'll add the different CFM. 15,000 for cooling, 12,000 for heating. If I uncheck this box, then I can go through all those loops and loads and put a different load in for each one. If you imported the loads, then that will be filled out here automatically. Then this is where you're going to see the fixture category type. So what type of apartments, condominiums, each of these different projects based on the codes have different type of heat recovery, right? And they also have different types of fixtures that kind of default to that type of a unit. You'll see 111. For some reason, your apartment's going to have, 2 showers or sinks or something. You can add that in here. So this is doing it per room on the project. And then minimum pressures that typically are seen from the codes. And then what type of heating source do you want? So we'll go with a boiler and an air-cooled chiller. Do you want a heat exchanger? No. Mixing storage tanks? No, we don't do that. Need one of those. No, holding storage tank, that's going to be, so when it's going to size the boiler, you can have an extra small storage tank and a larger generation, that'd be a larger boiler, or a large storage tank, and then the boiler would be sized smaller. And so you can just come in here, and even after the system's designed, you can come in here and change that and see how that affects the different sizing based on the recovery rate, right, of the storage tank or the size of the boiler. 1 boiler, 1 air-cooled chiller. What type of pump configurations do you want? Let's go with manifolded. A heat exchanger, so this is going to be the heat exchanger. So we're bringing domestic water in, right? On the domestic water, we want a heat exchanger because that's going to go to the fan coil heating plus the domestic water in the building project. What type of 1 pump there, 1 pump there, 1 on the heat exchanger. Any valves we want to put, we've added this IMI lately, the software have lots of balancing valves with expansion tank 1, air separator. You could have some ADI filter, magnetic filters if you want. If all goes well, we should have the, we did a 2 loop. I think we did 6 loads per loop. It'll build that and put that here on the screen for us. Doing a lot of calculations. So there's the hydronic hot water schematic. We should get this chilled water schematic coming out over here. I'll place that, puts it on my little cursor, and I just drop it down on the screen. Then we're going to get that little diagram that shows just how things are really piped up when that water, the piping gets to the room. Then we also have the load for the boiler to size the meter, the gas meter there. So now let's just, once again, I put that on top of that so I could go through the wizard. But there's the 2 pipes coming in. Here's the project. Once again, cascading temperatures going down through the project. That's seen by just dragging a box across, right-clicking with your mouse, looking at the temperature in the project, connector, temperatures, and see that coming down. So like I say, we've been doing this for years, but the difficult part and why a lot of people don't do a single pipe system or an integrated piping system is because of just the intensity to know exactly what are the cascading temperatures with all the flows whether it's from just a hydronic system alone or an integrated piping system where the both flows are integrated in that pipe. Hope this has been helpful. On that example folder, uh, if you notice there, let me go back to that particular one. That would have been this one right here. I kind of show and just mention some of the different flows and how they're seen in the piping, and just talk about how the pressure comes in. That pressure from the domestic system also helps that pumping system. So the pump only sees the hydronic heating or cooling flow in the system, and the pressure obviously from the domestic system adds to that pressure of that pump. So you don't need a higher pump head on this type of system. Once again, we'll be in Orlando next week at the HR show. Come by either our booth, Takeo or Williams. Learn more about this type of project or system uh, if you want to consider that on your project. Hope this has been helpful. Hey, thanks for watching.